tools and some constraints that we haven't really used before, and they've been there the whole time, but we haven't really used them before. So what I'm going to do is I'm going to make a sketch on the front plane. Okay, I'm going to make a sketch on the front plane, and I'm going to draw a profile. Now, there's different ways that you can do this, but I think most windshields are going to start similarly. We're going to draw a side profile. Imagine looking at it from the side. So the starting point is going to be a straight line for the bottom. So I'm going to start that straight line at the origin, and I'm going to go off to the right side. And that is the starting point because everybody's windshield has to lie down flat onto the wooden part of the car. So that part is going to be the same for everybody. Now, what's not going to be the same for everybody is the shape above as well as the dimensions. Those are going to change a lot. For me, I have the green truck. And the green truck is definitely not the most complicated. Probably the simplest is the orange sports car looking thing. The green truck's probably the second simplest. The blue van and the purple SUV are a little kind of cringe. They require, huh?
Is it because they have to?
They're just much more involved. They're just much more involved. There was people with stop doing my house.
It's just the one line there. 3 there.
Like, who does this?
Hey, but it wasn't me.
No, it's a 6 hour.
Wait, you had 6 hour engineering class?
Yes.
How come they don't do anything?
What do you mean?
How come you don't talk about them?
Because with rare exception, they don't cause problems.
Wait, is that like a freshman class too?
No, they're juniors.
So,
Is that a class?
It's
Or is it aerospace?
It's aerospace. And the capstone classes, 2 classes in one. So I'm going to measure I guess what you'd call like the width. So I'm measuring the like width of my windshield. Now this is easier said than done because you don't want your teeth to run at an angle relative to it. You'll overstate the length. So notice how I have it set up. Okay, this is so that my teeth are truly like parallel to the edges. Imagine if I try to measure it like this. The thing is this, like see how I'm rotating it, right? So there's no guarantee that you're getting a straight shot. You're actually getting the accurate depth or length or width or whatever you're measuring. Because there's nothing that's forcing your calipers to run perfectly parallel to an edge. All right. So I'm measuring it like this so that I get parallel. Don't squish on it too much. It's plastic and it will give. So for me, somewhere around 77 was a winning strat. So that's the dimension of my bottom. That was the easy part. Now, for the rest of it, I think there's a couple tools that you're going to want to find useful. First is arcs. You have all of these arcs, and we've already used arcs before, and you can use them. So I can do a 3-point arc, and I can get curved shapes like that. Okay? So maybe I make the end there line up, and I make this end like that. Okay? So let me do a pseudo windshield of 2 arcs. I'm not necessarily recreating this one. I'm just showing you something you could do with 2 arcs that looks kind of like a windshield. So I'm going to use a 3-point arc. I think it's the easiest one. Okay. So I'm going to start with 1 arc beginning at the front. And it's going to kind of go about maybe 80% of the way, 3/4 of the way. So that's 1 arc. And then I'm going to do another arc like that. And I know they didn't line up, and that's okay. All right? So I have 2 arcs. One that's like 80% of the width of it, and the other one's kind of the back end. And what you can do is you can use a tangent constraint. What kind of constraint? Tangent constraint. You use that So right here is a tangent constraint. And what I can do is I can make these two smoothly transition into each other. See that smooth transition? So now it's a seamless transition. And then from there, it's just about dimensioning this point here. Where do I want this point to be? And then I can change the curvature of these by grabbing the center of those arcs. So this point down here is actually the center of that arc. Okay. So I could shape this however I want. Maybe I want it to be shaped like that. Now, if you get the height, the problem is if you look carefully, I'm going to exaggerate this to make it more obvious. I hope you can appreciate that the highest point on this curve is not where the curves join. Do we see that? Yes, say yeah. Do we see that? Yeah? So how do you measure the height and then actually put in the software? Well, one thing you could do is you could draw a horizontal line. And you could apply a horizontal constraint to it if it's not already horizontal. Okay? But draw a horizontal line like that. And then just apply a tangent constraint to it. And make it tangent to the curve. And now I have a line that I can dimension to if I were to measure or figure out the overall height. So I can dimension to this line. So if I knew the height of my windshield, I got about 27. Somewhere around there. I could do the height like that. You can even make this a construction line, since you're not actually doing anything with it other than using it to measure. Okay? So I have taken a line, I have forced it to be horizontal, and then I've applied, you can see these constraints here, I've applied a tangent constraint to it to make it tangent to the curve. And that locks in the height there. And if I don't like that height or whatever, or these curvatures, I can change the curvatures of these by grabbing the centers. Okay. That's a way to get all or part of your profile, is with arcs and then using the tangent constraint. Do you have any questions about that before we move on? Okay, the other way you can do this is with the spline tool, which I have not shown in any way, shape, or form up to this point, at least not in this class. So the spline tool is right here. It is next to the polygon tool. If you look on the drop-down-ish arrow, you have some other options, all right? But I'm going to say spline. You don't want to use the Bezier. I don't think you want the Bezier. Spline is the way to go. So let's just go off to the side and practice drawing a spline. So when you click, every time you click, you notice you're basically playing, you're placing like a dot. And it's like kind of controlling the curvature of the shape. Okay? Each of these dots is what we refer to as a control point. Now, it's not very easy to edit a spline once you've made it. If you don't have the correct number of control points, that's what this drop-down arrow is for. You can click on this, and you can click Spline Control Point, and you can add another one. But that's it. You can also delete them, but you have to switch tools in to do this. So I can add control points. But what do the control points do? They allow you do, as I hope you can see, you can sort of manipulate the exact curvature of this. People like the spline tool. It's fun. It can be frustrating, but it's fun. And you'll notice that it's smooth the entire way. There's no jagged edges. We might call those cusps or vertices in like a geometry or math class. So I did this practice one over off to the side. It looks like an amoeba or something. I'm going to do a real one over here. One pro tip I'll point out. If you want to end drawing a spline, there's two ways to do it. Let's say I get to this point and I'm done. I only want those 3 control points. If I hit escape, it will go with the last control point I actually click to place. So I'll show that one more time. If I only want 3 control points, I place 1, 2, and 3, and then I hit escape and I'm done. Another thing you can do though is you double click to place the last. So I click, I know this is the one I want to be last, I double click to place it. All right? If you already have placed your last one, you just have to hit escape then. So I'm going to use the spline tool. I'm going to click here, 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 and then I'm going to double click to finish it. You do you. It's your car. Oh, you're good. So I don't want to draw anymore. I now have these control points, and you can see I can move them around, and I can adjust the shape or curvature of this. It's not easy to make this work with actual real dimensions that you're making yourself, because I don't know how you really measure that. But what you could hypothetically do, right, is I could hypothetically go a fixed distance in and then go up and measure the height to that distance. I could hypothetically do that, but that's not easy to do. So my recommendation would be to get some key measurements. One of them would be the height, and then from there, you can just ballpark it if you'd like. Now, if you're wondering what these white dots are on the ends, those control the angle that the end makes as it goes into its endpoint. So like this white dot was perfectly vertical. That would mean that this spline starts perfectly vertical. If I were to have this line go like this, I could make it come straight out of that if I wanted to. I could make this white dot. I could apply constraints as white dot, make it perpendicular or horizontal, not perpendicular, horizontal or vertical, aligned with something. How far the white dot is, you can see what it's doing here. It's sort of changing the size of the curve, basically. And if you don't like a control point, you can always click on it and then delete it. So I found it actually was better to just delete that one. I was having a hard time getting it to line up. So I just deleted that control point. So I actually only have 5 control points, 2 endpoints and 3 in the middle. And it got me this shape. So you do you. But I have gotten fairly satisfactory results with this. And about the only thing I'm going to do I'm going to do what I showed earlier. I'm going to draw a horizontal line. I'm going to make a tangent to the top of my shape. That's unfortunate. What did you call me? There we go. And I'm going to make it a construction line. So that's just so I can dimension the height. That's all I'm doing with that. That's the only reason why I'm even doing that. I think my height was 27, something like that. Obviously. There, that's good. Questions?
We did the Texans finish 3-15. No, are we talking something?
Okay. Next part's really easy. You just extrude this. Now, let's be smart here. What should I probably do with my extrusion?
Symmetric.
Yeah, I probably should do symmetric. And you can get the width very easily. You can get the width very easily. Calipers. This is the easiest thing probably to measure. I got about 65. And I have the beginnings of a windshield. All right, I get the beginnings of a windshield. Most windshields are rounded along the edges, the vertices. They go from front to back. So you aren't going to be able to get a precise measurement on that fillet radius, but you can ballpark it. So I'm going to use my calipers. Somewhere around 12. So I can do a fillet. I'm going to make it 12. And I can click on these two edges. And I filleted those edges. What feature do you think I will use next? Shell. Very good. Before I do that, I'm going to rename these things. Call this the windshield body, since this is the main part of the windshield. Rename this the outer fillets. So I'm going to flip this bad boy over, and I'm going to use a shell feature. So right here, I'm pinging it. This is called the shell feature.
I fixed the block. I made it actually work better for the saw.
The block.
That you had me do. For
What do you mean by block?
Board?
Oh, the blocker.
Yeah,
Oh, okay.
I actually reinforced it because
Hopefully
I had
it don't.
I delegated to Colton in it.
And it didn't. I love my man Colton, but it didn't work out. All right, I appreciate it, man.
So now it actually has 3 screws.
Hey, hopefully nobody dies now.
Well, it was just granting him, I'm pretty sure. So it really didn't matter.
True. You click on shell, Okay, shell thickness. You can get this with calipers. You can just measure how thick that plastic is. I got about 1.5. And then you just click on the bottom. Easy.
No, I haven't well,
So I'm going to click here, and I'm going to rename this outer shell.
Why is that?
You go ahead and leave.
I kick it.
Now, all of us
I didn't feel sick.
have a thing that basically sticks down below and goes into the passenger section of the car. And the dimensions for that are going to be similar for all of us. They're going to be similar. Okay? Now, if you actually look very closely at this, you'll notice that there's ridges. This is actually a little bit smaller than the wooden hole, but then those ridges make it stick in. Okay? And also plastic bends, which is not something that we can easily and readily replicate with our actual windshield. So, we're going to make some assumptions here. What we're going to do is we are going to assume we're going to ignore those ridges, and we're just going to make a rounded corner rectangle that's the exact same shape as the passenger section. So I'm going to click here, and I'm going to open a link in a new tab. And I'm just going to go open up my passenger section. If you ever do this at home, these kinds of things on Onshape, you may find that it would have been, in hindsight, it would have been more useful if all of these were different tabs in the same file. It would have been a lot easier. However, I think I told you guys the reason why I didn't want you to do that is sometimes because we have multiple people all logged in at the same time, sometimes there are going to be sync issues. And so if you have separate files, the worst case scenario, maybe you ruin one file in one part. Whereas if you had like 8 parts in one file and something happened to that file, you're cooked, right? You might lose all of your parts. So that's the only reason why we're doing these separate. I'm going to look at the top cavity. And these are the dimensions that I have. 50.3 and 40.6 with corners rounded to be 5.5. So that's what I'm going to do. I'm going to draw a shape, basically a rectangle of rounded corners. And I'm going to draw it on the bottom of the front, or sorry, not the front plane, the top plane. So if you look very carefully here, this plane that's being selected now, okay, I clicked on the top plane because that's exactly where my shape is resting on. And now I'm just going to draw a rectangle, and then I'm going to round the corners and dimension it. Let me ask you this. What rectangle? Corner rectangle or center point rectangle?
Center point.
Okay, the center point would be the obvious choice because it's going to be aligned with the origin or this axis. So I can draw a center point rectangle. Easy. And then I get the dimensions. So it's 50.3 wide and 40.6 tall. Now I have this rotated some. 50.3 and the other one's 40.6. And I can move that rectangle. Now this is a matter of placing it. Where is that rectangle? And I should only need one dimension. I just need how far it is from either the front edge or the back edge. And you can do whatever. But I'm actually going to use this hole depth gauge. I actually think this is better. Now, one thing you need to keep in mind is the centers of the sides of this piece of plastic are kind of bowed in. Okay? Basically, the reason why it's designed this way is they bow those in and then they put the ridge, and then only the corners and the ridges are touching rather than an entire surface. If you had an entire surface, let's see how big brains you have got. If you had a completely flat surface that was completely touching the wood, you would not be able to make it go down if it was a perfect fit. Why not? It's not because it'd be too tight, although that would definitely not help. Let's see how big your brains are. If this shape perfectly fit in here,
It wouldn't. You
flat on flat,
to take out.
it would be hard to take out, but it would also be hard to put in for the same reason, mind you.
It doesn't bend.
What?
It doesn't bend.
There's no
Well,
like.
Even if there was no friction, this would still be, imagine it poured a perfect seal there. Even if there's no friction, it'd be really hard to push this down. And if you did get it down, it'd be really hard to take off.
It would definitely be easier though.
Imagine if it formed a perfect seal.
You're not taking it out.
If you didn't have that gap in between the edges, where would the air go when you push it down? And if you did get it on there right, you'd now have a vacuum, right? Have fun getting it off. Now my wood is cracked, so I wouldn't have any issue, but like if this was not cracked, I mean there's no way you get that off of that vacuum seal. So my recommendation is actually measure to an edge. So watch what I'm doing here. Okay? I am measuring to an edge because their edges aren't bowed in, only the centers. So close to an edge. Not obviously on the curve, but close to an edge. And I got this about 21 away from the back end. So I'm going to double check that measurement. Let's go with 21. Oh, that's not what I want the dimension. I lied. That was a bad dimension. Not what I want to do there. I'm going to click here. I'm going to dimension from here to the very back edge. For me, I found it to be about 21. And now I just need to round the corners, and I had 5.5 as the radius, what I found last time. So I'm going to just continue with that. Sketch fillet, corner, 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 place, 5.5. Now let's see how big our brains are today. I have the profile made, right? Yeah. So now I'm going to go to extrude. How should I extrude this? Well, that would certainly be a good start up to next. And then do a second end position, and that one should be blonde. And I need to measure how high up that is. I got somewhere around 17.5. So I'm going to go over here, rename this. I'm going to call this the insert, because this is what inserts into the hole on the top of the passenger section. What do you think the last thing I'm going to do is?
Shell.
I'll do another shell. Now, you got to be a little careful with this. If you shell this a different thickness, your windshield won't be the consistent thickness then. This is about 1. So if I shell this with just 1, the problem is now my windshield is thinner there than it is out here. So that is an option. I could have done a shell. There's another option though. Go back to your sketch. I want you to go back to your sketch. So don't do the shell for this. You could, if they were the exact same thickness, but they're not. So I'm going to go back to this sketch. There is something I don't think we've used it yet. It's called offset. It's close to the scissors trim tool and the mirror tool. It's called offset. Okay? And you click on offset, and then you just click, 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 click. And it draws a perfect replica. Now, I'm going to grab this arrow to pull it in some. Okay, there's this arrow. But I have my offset. It scales it perfectly. And then once you're done placing the offset, a little dimension thing pops up, and that's the distance between the two, which for me I found was 1. I'll do that one more time. So I click here on this offset button, and I just go click on all of the shapes, all 4 sides, all 4 corners. That's what I want to have redrawn, but offset. And then I'll grab this arrow right here and make sure that offset's going inside. And then you can see my cursor has a mouse with a green check mark on the left click button. So I just click the left click button that finishes it. And this text box is asking for the dimension that separates. So you can edit that dimension later if you don't like it or whatever. It's right here. 1. And then when you go and you do your insert extrusion, you just select that little wall. So I've shown you a couple different ways to do this. That's it. That's the green windshield. There's one more thing I want to show you. I will go over this at the end. I'll ask you to do this at the very end. But one thing that's kind of cool, when you edit the appearance of something, not only do you change the color, but you can also change the transparency. So down here where it says part 1, you should already know how to do this. You can right click on it and choose edit appearance. You were supposed to do this for the puzzle cube. But in edit appearance, not only can I pick a color, like green, but I also have an alpha channel. I can control the transparency, and you can make it transparent. It looks really cool what you see and all that. And that's the windshield. So now I'm going to show what I did last year. So I'm going to go back to my last year windshield. I want to show you kind of what I did. Last year I did the vane, and that windshield was a little more complicated. And one thing you'll notice, if I look at it from this perspective, there's a couple things you're going to see. One is the sides are angled. So what I did when I made this, I drew a profile like this. I drew a profile. And then I extruded that profile. Okay. But then to get some angles, I had to do some other shenanigans. I called this the cleave. I basically drew this sketch. And you can see what this sketch did. I just drew a triangle and I cut through. And I cut those sides off. You got to do that before you do fillets or shelling. Something else with this was, this windshield was really wide and actually went wide enough that it overlapped the curve of the wood. And I literally redrew that right here. Most of the windshields don't reach this far to this size. This one did. And actually, the edges were rounded to go snugly over the rounds of the wooden body. And so I cut that out as well. And you can see that cut right there. Okay, you can see that cut. I did some other complicated things too, but that was stuff that I did before. I did that stuff before I did the actual fillets and shells. Okay. I think I've given you enough power, enough knowledge, I hope. Maybe.
How do you hide lines again?
Right here to the right and underneath the view cube, there's a camera and render options. And you can click if you hover over shaded with edges, you can change it to like shaded without edges,
Oh, that's.
which is like probably my favorite. We good? Okay, I'm gonna stop the stream.